Hello everyone. Today we are going to talk about LCM and GCF. That's least common multiple and greatest common factor. This is where we're headed after divisibility rules for Unit 2. I'm going to go through our notes for you since Fridays we are not in synchronous learning, which, like real word means we're not live. So here we go. Least common multiple. Let's start with that because those are your definitions. The least common multiple, or LCM, is the smallest number, other than 0, that is a multiple of 2 or more given numbers. Okay? In other words, least common multiples are talking about what happens when we multiply that number by 1, by 2, by 3, by 4, by 5, etc., etc., etc. That's why it is called a multiple. So for the number 24, multiples would be 24, 48, 72, 96, 120. Each time you're multiplying in order by number. 24 times 1, 24 times 2, 24 times 3, 24 times 4, times 5, times 6, times 7, etc. Those are multiples of a number. In other words, two numbers multiplied together to get the next version of that number. A greatest common factor uses the word factor, meaning the largest common factor or number of 2 or more given numbers. In other words, if for 24, remember we talked factors the other day, you got to multiply 2 numbers to get 24. You can do 1 times 24, 2 times 12, 3 times 8, and 4 times 6. All of those combinations give you factors of 24. In other words, 1, 2, 3, 4, 6, 8, 12, and 24. Those are all factors of 24. 1, 2, 3, 4, 5, 6, 7, 8 numbers. For the number 32, if I was doing multiples, I'd do 32 times 2 times 3 times 4 times 5 times 6 times 7 times 8. Okay? If I'm doing factors of 32, there's 1 times 32, 2 times 16, or 4 times 8. In other words, 1, 2, 4, 8, 16, and 32. So now for the fun part. When we start with LCM, or the least common multiple, I want the least or smallest number that both of those have in common, because it's the least common multiple. So I see 96 and I see 96. I also see 192 and 192. But the word least is what I'm looking for. So the least common multiple of these 2 numbers is 96. On the other hand, if I'm looking at factors, I want the greatest or the largest or the biggest factor of both of those numbers. So now I'm going to look for the highest one in common. All right, I see they have a 1 in common, they have a 2 in common, they have a 4 in common, they have an 8 in common, and I don't see anything else in common. So the greatest common factor is the largest number. And that's my GCF. Pause, rewind, listen to this again if that doesn't make sense. Moving on to the next 2 slides. Now I'm going to show you some actual examples and what we're going to use to find the LCM and the GCF. We're going to use something called the upside down cake method. Let me give myself some room here. Okay? First of all, let's go back to that example. Find the LCM and GCF of 24 and 32. That's both of them. I want to find them both. So here are your steps to find those. First of all, what number goes into both numbers? Okay? That's to find factors. So you're going to factor or divide out that number. Okay? You're going to take that number out of each of these. Then you're going to repeat that as often as possible. Okay? And what we're going to use to start and to make this easier for you is prime numbers. So if you remember, I told you guys you're going to have to remember those first 8 prime numbers. That would be 2, 3, 5, 7, 11, 13, 17, and 19. Those are the first 8 numbers that will come up most often when you are factoring or dividing numbers that go into 2 numbers. Okay? So, 2, 3, 5, 7, 11, 13, 17, and 19, I'm going to divide those out, and then I'm going to repeat that as many times as possible. So in other words, I'm going to start with the smallest prime number every time. Okay? If both of these are even numbers, I'm going to factor out a 2 as many times as I can. And if the 2 stops working, then I'm going to go to a 3. And if a 3 stops working, or never did, then I'm going to go to a 5. Then I'm going to try a 7. So we are going to factor out as many prime numbers as we can from both of these 2 numbers. And remember, people, they have to be a factor of both numbers. They can't be a factor of just one of them. You've got to pull both factors out for it to actually work. Okay? You'll kind of go down the line until you understand there are no other factors, and then you'd be done. Okay? We'll talk about what this means in a second. So now I'm going to use what we're going to call the upside down cake method. The reason we call it the upside down cake method is when you use a bar, which is kind of like an upside down division bar, and we do this as many times as possible to factor out all the numbers that are factors. If you can see this, it starts looking like an upside down birthday cake or an upside down wedding cake. So we call that the upside down cake method. And this is what we're going to use to help us this year to factor out numbers between 2 different numbers. Factors and multiples will show up once I show you that formula. Okay? So if I use 24 and 32, the first thing I notice about those 2 things is I'm going to put my upside down first layer of my cake. Okay? It's going to look like an upside down division bar. And I'm going to say, okay, that's an even number and that's an even number. I'm going to start with my very first prime number. And on the side, I'm going to put the number 2. And I'm going to factor out the number 2. So I'm going to take 24 divided by 2, and I'm going to write that next. And then I'm going to take 32 divided by 2, and I'm going to write that under both of those numbers. So the 2 numbers I have left are now 12 and 16. So I'm going to add my next layer to my cake, and I'm going to say, okay, they're both even numbers. I'm going to factor out another 2. So now I have 12 divided by 2 and 16 divided by 2. And those 2 answers are 6 and 8. And lo and behold, those are also still even numbers. So I'm going to factor out another 2. And what ends up at the bottom is 3 and 4. Can I factor out a 2 from a 3 and a 4? No, I can't, because 2 does not go in evenly with 3. 2 does go in evenly with 2, but remember what I said, you've got to be able to have a common factor or you can't pull it out. Thus the reason why we call it greatest common factor. If it's not in common, you can't take it out. So now I am finished. Okay? How do I find the GCF or the greatest common factor, I take all of the factors that I have taken out. And I circle those, basically everything on the left side, and I multiply those numbers together. So 2 times 2 times 2 is 8. 8 is my greatest common factor. If you look at 32 and you look at 24, that's the greatest thing they have in common. Okay? Those were all the factors that we took out one at a time, and I multiply them together. I don't add them. I multiply and I multiply. So my greatest common factor are all of the factors on the left that I factored out. How do I find the LCM? I now take my last two numbers and I circle them. And if you notice, that makes the letter L. So that's how you can remember LCM. The least common multiple are all the numbers on the outside of my upside down cake multiplied together. Now I have 2 times 2 times 2 times 3 times 4. And that gives me my LCM, or my least common multiple. Okay? If you look back at the first two slides, this is how I would find both of those answers using the upside down cake method. If you would please pause, make sure you understand that, and we'll move on to the last two slides. The last two slides we have will show you more examples of what we just did. If I ask you for the LCM and GCF, or least common multiple and greatest common factor, of 12 and 18. I put my first layer in. My first layer, I notice once again they are both even numbers. So I take out the number 2 and divide 12 by 2 and I get 6. And then I divide 18 by 2 and I get 9. Now I look and I see 6 and 9. I can't divide by 2 anymore because 9 is an odd number. So now I move on to my second prime number, which is the number 3. And yes, 3 can be divided into 6 and 9. So I take a 3 out. I factor out a 3. So now 6 divided by 3 and 9 divided by 3 are 2 and 3. Now I'm done, because 2 and 3 are both prime numbers, and I can't factor anything else out that are equal for both. So I am going to circle the 3 and the 2, and that becomes my GCF. And then I'm going to circle the 2 and the 3, which you notice makes an L. So my LCM is 2 times 3 times 2 times 3. And that equals 36. So there are my two answers for that question. The next one I'm going to do is 30 and 38. So again, they are both even numbers. So I'm going to factor out my 2 and have a 15 and a 19 left at the bottom. They have nothing in common. So if there's no common factor, I can't take anything else out. Therefore, if 2 is the only number on the side, 2 is the GCF. Then if I circle my other 2, I may still have a little short L. 2 times 15 times 19 equals 570, and that's my least common multiple. Again, what that means is if I had multiples of 30, it'd be 30, 60, 90, 120, 150, 180, 210, etc., etc., etc. 38, 72, whatever's after 72, whatever's after 72, and eventually I would get to 570 before they are alike. Two more. Find the LCM and GCF of 160 and 32. So the first thing I want to show you and remind you of is, if we were going to do that the long way, thank you to one of my associates for drawing a picture of me. If I wanted to do this and use prime numbers, I would have to have 160 and 320. And the first thing I would do would be to take out a 2. And that would make this 80 and this 160. Then I would make my next layer, take out another 2, and that would be 40 and 80. And then I would make another layer, and there's another 2, and they are still even numbers. Oops. Yeah, that's right. And 20. And another layer. And last but not least, after I'm done with all my 2's, I would have a 5 and a 10. I believe you can see this. If I try the number 3, which is the next prime number, it doesn't work. So then I go to the next prime number, which is 5. And I'm going to show you that yes, 5 goes into 5 once and to 10 twice. So my greatest common factor is 2 times 2 times 2 times 2 times 2 times 5. Okay? In the picture up here, when you get good at this, then you are more than welcome to use non-prime numbers. But until you really get good at it, it's not a good idea to do that. In other words, 2 times 2 times 2 times 2, which are all of these 2's, is 2, 4, 8, 16. 2 times 5 is 10. And that's where you show the 10 and the 16. But until you have learned to use prime numbers, I'd rather you do this the long way so you don't miss one. Okay? And then, of course, I also have the 2 at the bottom. So my GCF is 160 times 2 is 320. Okay? I hope that makes sense for you. That gives you the long version. For the last example, again, I took out a 10 instead of a 2 and then a 5 and then a 5. So I'm going to show you right here. Here's 400, here's 150. First thing you could do is take out a 2, which makes that 275. I would try a 3. A 3 doesn't work. So then I would take out a 5, which makes this 40 and makes this 15. And then I would take out, sorry, I've lost track here. Then I would take out my last 5, which gives me an 8 and a 3, which I can't actually show you there. I could show you here. So that's still 2 times 5, which is 10, times 5. I hope this makes sense for you, and I hope that gives you a good idea of what we're going to go over on Monday. Have a great weekend. Talk to you later.